Tell us a little bit about yourself.
So, I am Nadia Mazzino, Hitachi Rail. I am in the railway family since 30 years, so a long time, and always involved in technical activities. I started as a software developer, then engineering, innovation and R&D, and now I am the responsible of the new products and solution for the last generation of control centers and for the digital services based on data, on artificial intelligence to be added to our system. My company, Hitachi Rail, for giving you some more detail about this context, this word, which is not such well known and familiar to most people. So my company is dealing with all the different solutions for our customers. Our customers are national organization, national transport organization, infrastructure managers, local authorities, so depending from the different, of course, kind of business. We are engaged with urban solution like metro and tram. We are engaged in mainline, high speed, freight, and for all of this we can manufacture and maintain the trains and deliver signaling system and all this kind of let me say, operation and maintenance solution to be delivered to our customers.
So do you actually operate for some of these other areas, or do you hand over?
We can hand over to customer, or we can operate and maintain.
Okay.
It depends from the
maintain and operate.
Yeah.
Julian, I know a lot of people already heard you this morning, but let's have, in case somebody missed your session, let's talk a little bit about what you do for Mercedes-Benz again, if you don't mind.
Yeah, thanks, Vijay, and thanks again for having me. And yeah, I work for Mercedes-Benz Research and Development North America. I've been asked many times over lunch. I'm not coming from Germany. Yeah, I just came from the Bay Area over here. Not as long.
That's why I didn't think
you are the coming from far away one, definitely.
I got it there first.
just an hour flight for me, but well, I'm the distinguished machine learning engineer for Mercedes-Benz Research and Development North America, and well, what we basically do is we deploy the customer-facing AI, including Gen AI, into our vehicles. I said it before, and I also heard that over lunch. Yes, we build devices. They just used to be very, very big and very heavy and very luxurious, but still it's a customer-facing device that you need to interact with, and we basically, do the AI components for that.
So when we were designing this panel, one of the ideas that we had was so we think managing, deploying AI in capital-intensive industries is quite different from, say, financial services, lots of heavy assets. And so we decided to come at this sort of from two angles. Julian's really going to represent sort of the end product. So how do you use AI to enable the end product, which in his case is this heavy device we call the car, and all the reviews of the EQS 450 are amazing. And Nadia actually represents, we're going to ask her to talk more about sort of the operations, because she runs these very, very complex operation centers. And if you just think about, all the different things that must happen to make sure that the railroads are safe. This is like, most of us in the US, we're not very good with rail, so we don't sort of have an intrinsic sense of how it's run. But air traffic control is sort of the closest parallel that I could come up with anyway. So these are two different scenarios in which AI can play a very important role. So Julian, I'm going to go to you first. We talk about AI in terms of facilitating higher and higher levels of productivity. But productivity is not just about labor productivity in the sense like some worker does more with the technology, because you can improve productivity by adding to the value added of the firm, right? So, better products for which you can charge your premium divided by the same labor input gives you a productivity increase as well. It can be new processes, new tasks, new skills. So where has AI made a significant difference to Mercedes-Benz, and What has AI allowed you to do much better than the state of the art a few years ago?
I mean, again, in my function, what I really can speak about is what AI really allows Mercedes-Benz to do is really elevate the customer. I said that many times now for good reason. It really elevates the customer experience. I just call it the good old days. Basically, we have to rely on the fact that we understand our customers well enough that we implement functions in the way that they are kind of natural to use for our customers. We have to make a guess there to a certain extent. Of course, there's research and other things, but to some extent, our customers had to use their vehicles in the way that we tell them to use them. And Gen AI turns this absolutely upside down. I mean, we heard about everybody's talking about use cases or user journeys. And I'm not even questioning that, but let me bring you another perspective there. Gen AI has a somewhat general understanding of what you want from it. And on the other hand, you can also tell Gen AI what it's able to do. For example, controlling the functions in a vehicle. And all of a sudden, you don't have a use case anymore that you have to think about. You actually have the customer decide on their own user journeys. Because now you have that thing in the middle, let's call it Gen AI, which is able to moderate between the intent of the customer, which could be a very cryptic voice command, for example, and triggering the right action in the car. So what Gen AI really brings for us as Mercedes-Benz is that the customers can decide on their own user journey.
So I want to follow up with one thing there, because you were clearly first out of the gate with Gen AI, because we had Philip here last year in the audience, and he spoke about it. But what did it take to sort of just be so quick out of the gate when most other companies were so slow to sort of, and many of them are still not deploying it?
I mean, there's two aspects to that. One of them, our day-to-day is almost not that much about the models themselves. It's because they're there, you use them, you train them, you take them, but they are out there. It's really, you need to have the possibility to deploy them in your product. You need to have the flexibility, especially in the car industry. I mean, they're big vehicles, right? They're big things. They're planned years ahead, especially when it comes to the hardware components. And all of a sudden, there comes Gen AI, which literally changes every 2 weeks, right? There's something new every 2 weeks or every week. So the real important part here is actually not the models themselves, but having the possibility, having a platform to deploy those models fast and reliable and sustainable in front of customer. And well, it's all about having a reliable software platform out there. And I think at Mercedes-Benz, we did a good job with that. I work for part of the company called MBOS, right? The Mercedes-Benz operating system, which is basically just describing that we have a software platform which lets us deploy software flexibly, or with a lot of flexibility, including Gen AI. That's one component. And the other component is, and this has been heard many, many times, is talent. Gen AI is not easy, let's put it that way, and you need the right people to not only use it or to train it or whatever, but to deploy it. And I think both are checked on our end.
Thanks. Nadia, your turn. So you've been doing this for a few years now.
Yes.
So if you compare sort of what you're able to do today with, let's say, 3 to 5 years ago around sort of this, these complex control centers.
Yes.
What's changed for you?
I take a couple of minutes for giving some context information.
Yes, because it's not something that we get naturally.
First of all, railway. Railway is a very complex systems of systems, because you have physical elements like the trains, the infrastructure, dealing with a lot of different technologies which are to be deployed, to be available on board, wayside, and in the control center. So we have all these different interactions.
You said on board, on the side, and in the controls. Okay.
Yes, everywhere you have technologies and you have a physical, and every element is linked with the other elements. Okay. And the overall traffic management has to be deployed and, let me say, delivered under specific rules which are based on safety critical aspects or non-safety critical, but always we have to adhere to very specific norms and rules of the sector. Let me say, this is a first item. Second item is the life cycle. Last year, we started a design phase for a metro system, which will be in revenue service in 2030.
Oh, wow.
So this means that the products have a long life cycle, and we need to enter in this scheme for adding such quick news coming out with artificial intelligence and to be added to our products. So taking into account that for the sector now we have four main, let me say, pain points, which are the one of increasing capacity, reduce cost, reduce emissions, and improve the customer experience. The artificial intelligence, the innovations that we are bringing to our products are mainly focused in improving these four areas. And so the traffic management is now able in adding the first level of optimization. Of course, we need to improve more and more, and so the evolution is needed for the next years. To reduce cost through, mainly through the maintenance improvement, predictive maintenance activities. And during last week in Otrans, we, let me say, we came out with a brand new solution, HMAX, which is bringing in a unique all the asset management for improving the maintenance activities. Again, emission optimization of the overall for reducing the energy consumption and mobility support to the customer for
what is mobility support to the customer mean?
So our customers are mainly driven by operators through apps, timetable, and whatever. But thanks to the information that we have in our system, we can bring also to the customer or to our customer or final customer additional information for having a smooth transition between different modalities of transport.
Great. So, Julian, I want to go back to something that you said that I think often gets lost. One of the things you and I talked about was, and you mentioned it now, as the software platform, and you said something, you said, let's not forget that AI is also a piece of software. And I think it would have implication for Nadia as well, because she's running railroads all over the world. And so they have to take a platform-based approach. What were some of the, and when you built the platform, MB.OS, I'm guessing, what was you thinking at the time, in terms of building this flexible platform that you probably weren't anticipating AI when MB.OS was designed and built?
Not at all. And still you can deploy it, which is amazing.
Isn't it amazing?
That was one of those happy moments. Yeah, we can do that. Let me think about it. Yes, we can do that. And that's incredibly powerful. Well, at the end of the day, especially in the technology sector, in the software sector, things are moving incredibly fast. And in GenAI, I said before, something's happening every week. And especially if you have products out there in front of customers, which they are not software. They're real things. They have hardware components. They have, metal, plastic, and steel. You need to build those devices, those vehicles in a way that you're just ready for the future, right? And I mean, the term software-defined vehicle, I mean, I guess everybody has heard about this, is a very real one. That a lot, in the good old days, you had a vehicle, it had a steering wheel, some wheels and so on, and that's it, it could drive, yeah? It had a radio, okay. But a lot of functionality of vehicles these days are defined by software. And that's a good thing because then, you know, Gen AI comes around the corner and you take it and you deploy it. You know, you have a whole new, something that we never thought about when we had those car lines like the EQS, for example, right? I mean, we didn't know about Gen AI when that thing was ideated, right? And still you're able to deploy such things easily. So, you know, it's all about building in that vehicle business, it's all about building a platform which lets you not only deploy software fast, but also in a, you know, in a sustainable and also, you know, also safety in a safe environment quickly. And I think just, again, I say it again, that moment when we said, yeah, we can do that. Never thought about it 5 years ago, but now we can do that. It's a very rewarding moment. And
that is the beauty of software, right? Because software is cumulative. It grows and grows and grows, and you can add brand new functionality on top of it, provided you've actually developed it well. I think that's sort of, and who knows, as you said, who knows where Gen AI is going to go next, or AI more broadly. But I do want you to say one thing, and I know you don't work on this, but talk about what you're now allowed to do in Germany in terms of self-driving and speed.
Yeah. I mean, I think it was actually 1 or 2 weeks ago that was announced. So, I mean, first of all, we were the first OEM who actually by law is allowed to basically have level 3 on the streets. So level 3 of autonomous driving means that you can be completely hands-off. You just need to be able to take over within a certain amount of time. So that's level 3. And we were the first OEM to be allowed to do that in Germany, California, I think in Nevada, and probably a few other US states by now. It was 60 kilometers per hour initially, so that was where we were last year. By now it's 95 kilometers an hour. What's that in miles? I don't know, something like 40. So it's not a lot, right? But you see a clear trend here. You can almost go 100 kilometers an hour, and you can be completely hands-off. And eventually, this will open up a whole new in-car experience, right? And I just again find it very rewarding to see the trajectory there, right? I mean, once you're at 120, 130, then you're really in the game.
Yeah, because I mean, you're almost approaching the U.S. speed limit of 65.
Yeah, that's what I'm saying.
Right. Yeah. Though where I drive, nobody at 65 miles an hour, you'll be the slowest person on the road.
I mean, that's the thing in Germany with 95. You know, and people go very fast there, but it
is interesting how people like the other companies which shall remain nameless have been stuck at level 2 for quite a while, and here's Mercedes, which comes in at a level 3, which is fantastic.
As a certified technology.
Certified technology. Okay. Nadia, one of the things you and I talked about was Julian's lucky in a kind of way because, A, he works for Mercedes-Benz, but B, he doesn't have to worry about yet, vehicles talking to roads. I mean, they may on their own, but in terms of regulation or vehicle to vehicle, but that's coming. But you are dealing with that every single day.
Yes.
Because you mentioned already by the side of the rail, on sensors everywhere, and you've got trains that probably don't necessarily work. Like if you're dealing with one part of the rail system, the metro, but not the intercity part, then
yes.
How do you manage this complexity?
Let me say, this complexity is managed at a lot of different levels, of course, and different levels depending on the specific system that we are dealing with. Because inside the metro, as an example, we have since Hitachi Rail was not yet Hitachi Rail. In 2002, we delivered the first driverless metro. So it was for the time, a great innovation.
I'm sorry, what year did you say that was?
2002.
I thought I heard that correctly.
Yeah.
I'm like,
In Copenhagen.
okay.
Yes, and it is nowadays almost every metro that we are delivering are based on new, let me say, signaling system, evolution of the control center, but are still driverless. What we are aiming is to bring the driverless approach also on the railway, which is much more complex because, of course, the metro is a protected environment very often. The railway, you are in the open space, open air. And so the train must become more and more intelligent because must be able in understanding what's happening around. And what we are adding to the train, and this is part of the collaboration that we are having with NVIDIA and with the great support of Hitachi Digital, we are bringing on the train edge capabilities for checking around what's happening. For maintenance purposes, I am looking at the infrastructure for understanding if something is wrong, but also for safety, because I have to check that the way is free for the train.
So what does Hitachi bring to the table, and what does NVIDIA bring to the table in this partnership?
So Hitachi Rail is bringing to the table the operational technology expertise. So the people knowledgeable of the domain, of the product, the trains, and the overall, let me say, railway system. Of course, we have Hitachi Digital, which is supporting us more and more with IT competence, which allow us in accelerating a lot the introduction of innovation and innovative technology. NVIDIA brought the strong competence, the disruptive innovation on the edge capabilities in this specific application, and we, in an unbelievable quick time, very short time, were able in moving from a meeting in a room to InnoTrans demoing to thousands of people.
Now, were these sensors already on the train, or do you have to add?
So in this case, we had already sensors on the train, cameras, but the images collected were post-processed. So were brought in a control center, in a cloud, and then people were using images, applying algorithm and post-processing. With this application, we will be able, in running in real time, in the meanwhile the train is running through, running all the algorithm and alerting at once in real time for critical situation. What is really impressive is that we can run not only one technology, one algorithm on the edge, but we can add, in order to transform the train more and more in a sort of robot, let me say, look around what's happening.
And can these edge solutions also take actions, like it says collision, imminent, slam on the brakes?
You can. So this is a second step. So the first step is mainly for the diagnosis and for warning. After, what you are speaking about is linked with safety stuff. So for achieving this automatic link, we need to run through the process of safety, which means testing, procedure, and so on and so forth. And so this, but this is the next step, of course.
Julian, you, when we were planning, said you'd liken Gen AI to a Swiss Army knife. So, or what we call a general purpose technology. So what is Gen AI allowing you to do, and why is it important?
To some extent, not only me, but mainly our developers, right? It allows us to do the things that we have not thought about yet. I think that's a fair summary of that. I made this example earlier with the snow sensor, right? I mean, Gen AI can tell you if it's snowing. Right? This is it's a simple prompt. Give it an image and a prompt, of course. I mean, it can be night and so on. Things are not that easy, of course, but Gen AI just reaches a certain level of like general abstraction. It becomes, I mean, we heard that before. AI today is still incredibly narrow, right, and nowhere near any kind of AGI. But within its limited narrow space, it is fairly general. And that's what I mean with Swiss Army knife. It's it's the Swiss Army knife which has a lot of features actually. It allows you in terms of when you try to bring an idea to the street, then if you have access to a Gen AI model, it will make your life a lot easier because you don't need to implement that thing. It can be a simple prompt, and you have that thing you have the Gen AI model generally available. You just call it via an API, and all of a sudden, your user journey, your use case that you had earlier as a developer, which was, I don't know, a few thousand lines of code, probably comes down to a few tens or hundreds lines of code, and A, that allows you to innovate incredibly fast, and B, it also allows you to innovate incredibly efficient.
No, one of the things you said was in the old world of just predictive AI, you had to have a classification algorithm and rules for, or not even rules, that's not the right word anymore, but sort of systems that could diagnose or analyze any single feature. But now generative AI is general purpose and that you don't need the classification algorithms anymore.
As I said, what I said earlier, and I stand to that, is we don't even, I mean, in our current thinking, we are not even implementing user journeys anymore. We are just implementing enablers to decide the customer what she or he wants. And
that's, because I was been around and I was very involved in sort of when people started navigating the internet, particularly for shopping, the whole idea of user journeys was a very big topic of conversation, and in some ways you don't have to do that anymore. So that's actually very powerful. Let me ask them one more question, and if you could queue up your questions, that would be great. So, Silicon Valley has the advantage that they always talk of this language of fail fast, fail forward. You obviously cannot do that. Nobody's going to be happy with you if you fail fast, right? So you have to do a lot. Actually, for that matter, he doesn't do the self-driving, but he's got the same. He's doing the fun part, the entertainment part. And I'm giving you a chance to warm up. I'm going to ask you the question about the most unexpected use case for the Gen AI in your car. But now to talk about the culture of building software and solutions in something that is as critical as rail.
Yes. As you said, and linked also with the life cycle of our system, we cannot be such quick as should be nowadays. So what we decided in our strategy some years ago is to be prepared, let me say. And so to build a framework ready for integrating innovation based on a standard, let me say, a standard data model. We did this big effort in modelizing all the assets around the railway system, standardizes this model, and in this way, every single pieces that we are going to add or to modify can be, let me say, ready, plug in bracket, because we defined this common language. Okay, so this was a huge work done. I think that this could be the way forward for being ready for what will happen next year, 2 years, in 2 years from now. Let's hope.
And the reason I emphasize this is because I think all of us live in systems of systems. But the way we've approached solutions in the world as we know it is we all solve within our own domains. But Meghna was talking earlier about sort of integrating all the models within Verizon, but you can certainly see a world where integrating models at city scale or even national scale. So I think these kinds of conversations are really important